Hello everyone, Uday Shankar here. Welcome to my channel Knowledge Share to Delete Ignorance. This channel is created to share the knowledge of known ideas to the unknown society. And today in this channel we will be discussing about solar energy conversion part 2. Already in this channel we have discussed about the solar energy conversion, and those who have not watched can please click the I button on the top of this and you can watch it and you can come back to the session. And kindly subscribe to my channel and press the bell icon for future notifications in this channel. Also, if you find that this video will be useful to someone, please share this video to your friend circle. And now, let's go into today's topic, solar energy conversion part 2. Okay, welcome back. And first I will give you an overview of presentation, and then we will discuss the topics in detail. So in this session, first we will be discussing about the classification of solar energy systems. So as you all know that the solar energy systems are widely used, and it has been classified into three different categories. The first one is standalone solar PV system, and the second one is grid interactive solar PV system, and the third one is hybrid solar PV system. Hybrid solar PV system is most widely researched nowadays as it is more economical and highly reliable. So this is the most important for remote locations. Okay. And so in this session I will be giving you more details regarding the hybrid solar PV system. So in hybrid solar PV system, first we will be discussing about the block diagram and working of PV diesel hybrid renewable energy system. There are many types of hybrid, that is HRES, and in that PV diesel is most famous, so I will be discussing on that. And then it is having three different configurations. That is, the PV diesel hybrid system is having three different configurations. The first one is series configuration, and the second one is switched configuration, and the third one is parallel configuration. So we will be discussing one by one in detail. And then we will be moving on to that is, we will be discussing about what are the advantages and disadvantages of the above three systems, and also the working will be discussed. And finally we will be closing this session after the discussions related to how to control this PV diesel hybrid system in an optimal manner to achieve the better performance and high reliability and good efficiency and longer life. So it has to be operated in 6 different modes, and we will be discussing about all the 6 different modes in detail. And now let us go into the first topic, that is classification of solar energy systems. So as you know that the classification of solar energy system, there are three types. One is the standalone solar PV system, grid interactive solar PV system, and the hybrid solar PV system. So now let us discuss one by one in detail. So first we will discuss about the standalone solar PV system. So the main components of the standalone solar PV system is shown in the figure. Here you can see that an MPPT is used. An MPPT controller is used, which is going to adjust the operating point. So hope you are clear with what is the operating point of the PV panel. So it will be the MPPT will be adjusting the operating point of the PV panel such that the maximum power is being extracted. So MPPT is used to extract the maximum power. So there are many different techniques, and here we are not going into the techniques, but here just we want to understand that MPPT is going to extract the maximum power. If MPPT is not used, then 5 times less power only can be extracted. So that's why in all modern solar power systems, MPPT technique is compulsorily used for extracting the maximum power output from the PV array. So the output from the PV array is first converted to DC. That is, it is actually DC output. That is, the output from the PV array is a DC, and that has to be converted to AC, and then it has to be fed to load. The PV array output in excess to the load requirement is used to charge the battery. If the excess power is still available, then it may be shunted to dump the heaters. It may be shunted to dump heaters. Why it is done is because the load and the generation should always be almost equal. If the source is very high when compared to load, or if the load demand is very less when compared to source, then it will result in high frequency deviation and voltage deviation, and therefore the dump heaters are used. And similarly, when the sunshine is not available, or when the sunshine is very less, whatever energy that is being stored in the battery earlier, that will be supplied through the inverter to the load. The battery discharge diode DB, you can see that there is a battery discharge diode DB, and this battery discharge diode DB is used to prevent the battery from being overcharged. The array diode, there is an array diode DA which is connected in series with the PV array, and this is used to isolate the PV array from the battery and to prevent the battery discharge to PV array during the night times. A mode controller is also used, and which is acting as a central controller, and this collects the system signals and keep track of the state of battery and the load matching with generation, and it sends the command signals to the battery charging as well as discharging, and also it is going to control the switching on and off the dump loads. Is it clear? So hope you are clear. So this is the block diagram of the standalone. Okay, so this is the block diagram of the standalone system. Here from this diagram you can see that that is the standalone system, solar PV system is having a array diode. So this is called as array diode. This is called as the array diode, okay, and this is called as the blocking diode, which is used to prevent the overcharging of the battery. Okay, so here the PWM switching regulator scheme is used in order to supply the sine wave to the loads. So this is a standalone solar PV system, so there is no grid connectivity here. So the standalone solar PV systems are used wherever the grid connection is not feasible. For example, in remote areas like mountains and forest areas like that. Okay. So this is the dump load. So what is the use of this dump load? So dump load is used to, for example, if the PV array, solar array, there is a source is very high, then that has to be that has to be supplied to charge the batteries, and if it is even more high, then that has to be supplied to dump load in order to meet the generation and load. Okay, so otherwise the generation will become more than the load, and that will result in frequency deviation. I hope you are all clear with this. And this is the MPPT controller, and MPPT controller is used to check for the maximum power point. So now we will move on with grid interactive solar PV system. So grid interactive solar PV system, you can see that this concept can be implemented only in urban areas or where the grid connectivity is available. So this cannot be used in remote areas or in villages, extreme villages, or in forest or mountain regions where the grid is not available. So always this system can be implemented only where the grid is available. Power grid should be available. So here there is no need for battery. You can see that there is no need for battery and there is no need for dump loads. Why? Because the whatever excess power that is being generated when high sunshine is available, that will be exported to grid, and therefore there is no need for any dump heaters and batteries in it. And during the absence of or inadequate sunshine, the supply is maintained constant by importing from the grid, and thus the battery is also eliminated from this. But there is a problem, that is the synchronized operation with the grid is to be incorporated, and hence high high power quality should be maintained. IEEE standards has to be maintained. Power quality should be good. So that is a very, very important concept here, because grid will accept only pure power. If there is any harmonics inside it, then immediately it will be transferred to the other loads which has been connected, and hence penalty has to be paid. So always the grid has to be connected, or it has to be synchronized only with high power quality being exported to it. And the PV array's DC output power is converted to AC by using the inverter, and in that we will be using some filters which is going to filter the harmonics, and then only it will be fed to the grid. So this is the concept behind the grid interactive solar PV system. So here you can see that this is the array field and this is the MPPT controller. So what is the use of the MPPT controller? Is to extract the maximum power point from maximum power point operating point of the solar panel, so that the maximum power is being extracted. And this PWM switching scheme is used in order to convert the DC power which is available over here to AC. Okay, so this is the so again this inverter is going to convert it to AC, and then it is be fed to the grid. So here you can see that the grid is there, and this transformer will be a step up transformer, as the voltage level will be less when compared to the grid voltage. So there should be a step up transformer, and using the step up transformer it will be exported to grid. And if there is any local loads also that can be supplied by means of this grid interactive solar PV system. So hope you are all clear with the block diagram explanation of grid interactive solar PV system. So now we will move on with hybrid renewable energy system, that is where we will be using, that is in both the previous cases we used only the PV. The first case standalone, we used only PV that will be supplying to load. In second case, PV along with the grid was supplying to load. Now this is the third case, this hybrid solar PV system. See, there are many remote locations and forests and mountains where the grid is not available. And also, if you expect only the PV to supply to the load, then the sizing of PV should be very, very high. And also the PV will not be used in a very efficient way. In order to avoid that, the Diesel HRES is to be incorporated with the PV. Why this is done is because PV is not continuous in nature, it is highly intermittent in nature. So all the renewable energy systems are highly intermittent in nature, and hence this is the main drawback. Okay, this is the main drawback, that is the energy supply is not continuous due to the instability in nature, and hence HRES is the suitable method for the remote locations like mountains and forest regions. HR regions is more advantageous over the standalone and grid connected for remote location because of its high reliability and less cost. So it is very, very less cost when compared to the grid connectivity as well as the standalone system. And there are many three different types actually for the PV HRES. So you can see that the three different types are PV diesel, wind PV HRES, micro hydel PV HRES. So these are the three different types, and we will be discussing one by one in detail. So, but in this case, we will be discussing only the PV diesel HRES, which is the most widely used technologies nowadays in order to meet the remote location power demand. So now let us go on with the discussions related with PV diesel HRES. The PV diesel HRES, already as I told, it is used for remote location, remote villages and forest areas, and similarly in mountain regions where the grid is not feasible. Okay, grid connection is not feasible. So this consists of a PV array, a DG set, that is the diesel generator set, and a battery bank. Whenever power from PV array and battery bank are not sufficient to meet the load, then the diesel generator set is switched on. The diesel generator set also charges the battery bank. The PV, as per the survey, it has been proved that when this type of system is used, the PV has replaced nearly 90% of the diesel fuel. So this is the main advantage of the PV diesel HRES system. The PV diesel also ensures continuous power supply and cost effective compared to the standalone PV and standalone DG sets. So here you can see that the PV array through this charge controller, because the PV array is going to generate a DC, so this has to be converted to AC using the inverter, because the load is AC load is 50 Hertz AC, and that has to be converted. And whenever the load is less, you can see that maybe the PV is very high, okay, and load is less, then this will be supplying both load plus battery. So battery will be charging. But in sometimes what happens is when PV will become less and load will become sometimes high, and therefore this PV will be supplying only to load. PV will be supplying only to that is PV will be PV plus battery will be supplying to load. So this is the second case. So like this, and similarly, suppose if the PV is not there, and PV is not there, and also the load is very high, then what happens is the diesel generator will be switched on in order to meet the load. So these are the different conditions. And if the load is very high, again you can see that the battery bank also will be supplying to the load. And suppose if the DG is suppose for example if suddenly the load drops down, and DG what will do is it will start charging the battery bank, so that the battery bank stored energy can be supplied whenever the load demand increases. So this is how it operates. So moving on to next, we will discuss about what are the different configurations. So what are the different configurations of that is PV diesel hybrid renewable energy systems. So as I've already told, there are three different configurations. That is, one is called as the series configuration, switched configuration, and the third one is called as the parallel configuration. So each and every configuration is having its own advantages and disadvantages. And I just want to make you clear that the series configuration is the most oldest technology, and nowadays it is seldom used. Nowadays all the technologies has been implemented using the switched configuration and the parallel configuration. Anyway, the series configuration, even though it is an old technology, it is used now in even though the new implementations are not there, but older technologies are still even using the series configuration. So why it has been seldom used is because it is having certain drawbacks when compared to switched and parallel configurations. So now let us see what are the advantages and disadvantages of different configurations, and how and where we can use different configurations and different streams. So now let us move to discuss about the series configuration. So from the figure, you can see that the series configuration, you can see that only one bus is there, that is the DC bus is only there. Whereas in other two configurations, you will be having the DC bus as well as the AC bus. So that is the first thing you want to understand. And here you can see that the diesel generator set and inverter are to be sized to meet the peak loads, because it has been connected continuously to the load. So it has to meet the peak load demands. So in this system, large portion of the DC, that is the diesel generator energy, will be passing through the battery bank, which results in increased cycling of battery bank and results in its reduced efficiency. AC power to be delivered to load is converted from DC to the regulated AC by means of the inverter. The power generated by the DG is rectified and converted back to AC, which leads to conversion losses. The actual load demand now will be met by PV diesel generator set along with the battery banks. The solar controller which is used will monitor all the states and it will prevent the overcharging of the battery bank, and also it takes care of the implementation of MPPT. The advantages of this system are that is there is no need for any switching between different energy sources, so there is no switches. So the power supplied is not interrupted. So this is the main advantage of this. And also the inverter is generating a sine wave. But what is the disadvantage? The disadvantage is inverter must be sized with the peak load of the system, as it cannot operate in parallel with respect to the diesel generator set. And also the battery bank cycling is frequently occurring, and this because of this the battery bank's life is getting shortened, and also larger battery banks are needed to limit the depth of discharge, and this results in lower efficiency due to the diesel generator set design with respect to peak demand. The inverter failure, for example, if there is any inverter failure, then this will result in complete loss of power to the load. So this is the major drawback of this particular system. So here you can see that is only the inverter is going to supply to the AC load. So the diesel generator, diesel generator is producing AC, is it right? And that has to be converted to DC using this rectifier unit, okay? And that will be fed to the DC bus, and then so here you will be having the DC, and here the battery will be charging. The excess power from the diesel generator will be used to charge the battery bank, as well as a portion of it will be converted to AC and will be supplying to the AC load. And whenever the load is very less, the diesel generator will be off. And PV will be on. And the load will be met by the PV and the battery bank. Okay, so this is how it operates. So this is called a series configuration, and due to its large drawbacks which has been discussed in earlier, it is seldom used nowadays. So now let us go on with the discussion of next thing, that is the switched configuration. So you can see that from the figure, you can see that in switched configuration it is using two different buses, that is the DC bus and the AC bus. You can see that there are two different buses, DC bus and AC bus, and in between you are having the rectifier and inverter. And a switch is also there. You can see that a switch is also there. This switch is used to switch between the diesel generator as well as the PV and battery bank, which is being supplied to this particular bus. So either the load will be supplied from the diesel generator, or the load will be supplied by the PV along with the battery bank using the inverter configuration. So this is how it is going to operate. So here you can see that so this is the most commonly used installation today. It allows either diesel generator or the inverter as an AC source. The inverter is fed from the battery bank or from the PV array. The diesel generator and the PV can charge the battery. The main advantage compared to the previous system is that the load is supplied directly by the DG, and this results in high efficiency. So there is no conversion from AC to DC power from the diesel generator set, and because of which the efficiency is very high. The conversion losses are reduced, and because of which the efficiency is very high. When the DC generated, that is the diesel generated power is very high, then when compared to the load demand, if the diesel generated power, DG power is very high, then that excess energy will be used to recharge the battery. And during low loads, the DG will be switched off and the load is supplied by the PV and the battery bank. An automatic controller has to be implemented, which is going to control all the operations, whether it has in order to ensure that whether recharging of the battery bank is necessary, and which particular source has to be switched on. Load tracking, according to the load tracking has to be done according to the load demand. The sources has to be switched on. So this is the main operation. This is the operation and working of the switched configuration. So the advantages: the inverter generates a sine wave, and the diesel generator unit supplies the load directly, and this results in high efficiency. The drawback is power to the load is interrupted when the AC sources are being transferred. So this is the main drawback. So whenever the switch is being operated, you will be observing a slight discontinuous power. And so this is not suitable for critical load applications in hospitals and industries. So maybe in residential case this will be good, and for commercial complex this might be good, but whereas it is not suitable for hospital, as well as it is not suitable for critical loads like industries or something like that, because where the continuity of power has to be ensured. But this is less costly when compared to the previous series configuration, as well as the life is also good. That's why the switched configurations are mostly used nowadays in most of the applications. But wherever the critical necessary is there to maintain the constant power supply, like in hospitals and high industrial environments, then we have to go in with the next configuration, which is called as the parallel configuration. Now we will discuss about the parallel configuration. So you can see that in parallel configuration, again you are having the DC bus and AC bus, but there is a new component. Instead of the rectifier inverter, you are having a bidirectional inverter. So this is the one of the new concepts in the power electronic industry, that is the bidirectional inverter. And this takes care of all the things which we have, that is the synchronizing, switching, DC to AC as well as AC to DC, everything it is taking care. So that's why it is called as bidirectional inverter. The only thing is it is very costly when compared to the previous configurations, and but it is more suitable for the industrial applications as well as the hospital applications. So here you can see that all the energy sources supply to load separately at low, medium and peak loads, and because everything is combined by using the bidirectional inverter. So this is the main advantage. So there are several advantages in this scheme, like the system load is met in an optimum way and everything is shared. Okay, it is not like a switched in previous case, it is shared by all the three sources, like diesel generator set, your battery bank as well as the PV array. So it is shared, and because of which the rating is also quite reduced, and also the diesel generator unit efficiency is also maximum. Okay, that is the main advantage, because it is not operating in peak loads. Okay, so that is the main advantage of this. And similarly, the diesel generator maintenance is also getting minimized. Okay, the efficiency is also getting maximized, the maintenance is also getting minimized, and also it also results in reduction of rating of the diesel generator set, battery bank, inverter as well as the PV, because everything is getting shared. So that is the main advantage of this. But it is having some quite disadvantage, like the bidirectional inverter cost is quite high, and the automatic control is very important in this case, without which it will not operate. Whereas in previous case you can operate in manual mode also, but here the automatic control is very essential. And also the system is quite less transparent to the untrained user. Okay, and hence trained persons are needed to operate this particular parallel configuration mechanism. So this is one of the main drawback of the parallel configuration mechanism. And now we will discuss about what are the different control techniques that is used for PV diesel hybrid system. So as I have already told, there are 6 different modes: mode 1, mode 2, mode 3, mode 4, mode 5 and mode 6. So for example, in mode 1, let us take an example of early morning hours and late night hours. Okay, in this case you can see that the PV will not be there, and during night hours that is the load is also quite less, and because of which the battery will be supplying to the load continuously. But whereas Suppose if you go in early morning at 6 a.m., then load will be medium. It will be of medium nature. Load demand will be of medium nature. So battery will not be able to support that particular load, and hence PV also will come into picture to support that particular load. So PV and battery supplies to the medium load demand which is existing in early morning. So PV has started generation at 6:30 onwards, 6:30 am onwards, but in support with the battery it will be supplying to the load. And as the time goes on, like it is above 9 am or something like that, the PV will produce excess energy, and so that excess energy will be charging the battery, and also it will be meeting the medium load. But after 9 am or after 10 am, you can see that the load will be quite high, and hence the DG set has to be switched on, and that is called as the mode 4. The DG set has to be switched on, and along with the PV it will be meeting the load demand. And whereas in mode 5 you can see that so here in mode 5, along with the PV, this DG and battery also will be supporting the peak demand load. Okay, that may be at 2 to 5 or something like that. But after that you can see that the PV will be reduced because of low sunshine, and since the load demand is also reducing, so the DG set alone can be switched on to meet the load, and as well as it will be charging the battery, because the PV will be switched off completely after 6 p.m. and hence the battery will come to support in order to meet the load demand. So these are all the 6 different modes of operation of the PV diesel hybrid system. And I hope that this video will be useful to you, and if it does, please give this video a thumbs up. And if you want to see more videos like this in near future, please hit the subscribe button which is in the bottom right corner of the screen, and in that way you will receive notifications at any time, and the videos like this will be posted in our channel in near future. And that's all I had it for today. I hope to see you in the next useful videos in near future. Thank you very much. Bye.